Farina binti SUKARNO. Today I will explain about process flow of thermal power plant. Okay, this is a diagram or process flow diagram about thermal power plant. Okay, thermal power plant use water as a working liquid. Nuclear and coal use based on the power plant. The energy of the fuel will turn into an electrical form that functions as a power plant. In thermal power plant, the steam turbine is rotated with high pressure and temperature steam. This rotation is transferred to the generator to produce electricity. This is generator, cooling tower, turbine, condenser, pump, boiler, static precipitator and chimney. When the turbine blade is rotated with high pressure and temperature steam, the steam loses its energy. This system will produce low pressure and low temperature steam in the turbine exits. If the pressure is low, the temperature steam returns to the normal state. Then we can produce electricity continuously. This is turbine. Then the condenser will compress the liquid in large amount of energy. So before compress, the liquid must be converted into a liquid state. This is condenser. When out of the condenser, the pump will increase the pressure. The pump will increase the pressure. The liquid has regained its original. The heat is added through the heat exchanger that called boiler. This is boiler. The boiler increases the temperature and liquid will turn into steam and regain normal temperature. This complete thermodynamic cycle known as Rankine cycle. Heat is added by boiler in thermal power plant. The fuel can be coal or nuclear and produce contaminant and remove the contaminant before release to the environment by using ASP or static precipitator and through chimney. This is chimney. That's all from me. Thank you. In thermal power plant, the fuel can be coal or nuclear and produce contaminant and remove the contaminant before release to the environment by using ASP or static precipitator and through chimney. This is chimney. That's all from me. Thank you.
Assalamualaikum. My name is Nurhidayah and I will explain about the function of each component in our plant. Okay, first of all, we have steam generator. Steam generator, the function of steam generator is to generate the steam. In this generator, the cool is burned in order to produce heat. The heat is then used to convert the liquid into steam by heating process. Okay, next is compressor. The function by the steam generator just now, the steam will compress into the steam turbine by using the air compressor. Okay, next, the compressed steam will be enter the steam turbine. The steam turbine will rotate with the help of the high temperature and high pressure. From the compressor process help the rotation of turbine and is then transferred to the generator to produce electric. Okay, lastly is the refrigeration cycle. There is an important component in this refrigeration cycle. It is condenser. Okay, the condenser is used to reject the heat to the surrounding and convert steam into liquid. Hence, it can be concluded that the function of refrigeration cycle is to help the steam temperature to return its normal or ambient temperature.
Okay, Assalamualaikum warahmatullahi and good afternoon. So today our production plant, which is thermal power plant. So as to what you see is one of the cycle, and in thermal power plant we use a Rankine cycle. So first of all, today I want to explain to you guys about the details of the important in the equipment that been used in the thermal power plant, which is turbine, compressor, condenser, and also boiler, which is steam generator. Okay, so first I would like to explain to you guys about the turbine. So in this process of the thermal power plant, in the turbine, the inlet of the turbine must be increased pressure and also increased temperature. So at the inlet must be pressure is increased and also the temperature increased. So when the inlet is insert in the turbine, the steam or the hot gas will be dispersed inside the turbine. So in the turbine, the important component that can be out is first shaft and also blade. So shaft is the rotor that used to cycle up for the generator to make from mechanical to become the electrical. So for the blade is the part of the turbine that is the important part in the turbine. So in the turbine, the blade must be shaped in airfoil shape, which is like this. This shape, yeah, like this. This is airfoil shape. So in the turbine is used to rotating with a high pressure. So as I say that the inlet of the turbine must be in high pressure and also high temperature. So the outlet of the turbine must be in low pressure and low temperature. So at the turbine, in this thermal power plant, turbine is used in 3 stages, which is high pressure turbine, intermediate pressure turbine, and also low pressure turbine. So at the first, from the inlet, the hot gas will be passed through high pressure and then intermediate and also going past through to the low. So at the low pressure turbine, as I said, the feed will be going to low pressure and low temperature. So now the process will be going to the condenser. But then in our thermal power plant, the thing that we can use to make the output to become from pressure low to high pressure is by adding compressor. So the compressor will be used to increasing back the pressure, and we can make it the cycle going back to the turbine. Just no need to back to the condenser. But in this thermal plant, by adding the compressor is not too efficient at all, but can be used. So I proceed to the condenser. So this condenser, the inlet of the condenser, which is the heat reject from turbine. Heat reject that be in the condenser. So in the condenser at our thermal power plant, the important equipment that be inside in the condenser, which is in the condenser, there has a pipe. There have a pipe. The function of the pipe is to flow up the cold water, like this, parallel view. Yeah, parallel view, cold water inside. So when the cold water going to be cycled in the condenser, the heat reject that be in there will going up, pass through to the pipe. So at this situation, the heat reject will be condensed to become water back. The normal normal state water in a liquid form. So when it come in a liquid form, the water will be going to the out.
Hello, Assalamualaikum warahmatullahi wabarakatuh. Okay, after the water from the condenser, the water at the condenser is at low temperature and low pressure. Okay, at pump, the water is then increase the pressure to achieve high pressure water. Okay, at pump, the high pressure water is fed to the boiler. The next task is to increase the temperature of the water. At the boiler, normally at the high capacity plant, normally use type of boiler that called water tube boiler. Okay, this is actually a draft of the water tube boiler. Okay, the water from the pump is actually pumped into the equalizer. The function of equalizer is for to help increase the temperature of the condensate water and also minimize the energy to heat up the feed water, or generally called preheating process. Okay, after the preheating process, the water is then pumped into the water drum. After the water drum, the water is then straight to the downcomer. After the downcomer, the water is then heated up by using water tube boiler. Okay, the water tube boiler is heat the water from the wall of the reactor. After that, the steam generate, and the steam is then recycled back to the turbine. Then the steam at the high temperature and high pressure then is then used and recycled back to the turbine, and then Rankine cycle is achieved. That's all for the thermal power plant process. Thank you.
My name is Muhammad Zikry bin Kamisan, and I suggest that ultrasonic and visual inspection technique as NDT application in the thermal power plant. First of all, use ultrasonic technique for wall thickness measurement and scale detection. Scale deposition inside the boiler tube is a region of perennial worry at the power station. A handful of boiler tube failure case can be attributed to scale deposition. The scale are mostly composed of iron oxide and in some cases CaCO3 and certain other compounds depending upon chemical reaction and the nature of water. Purification of river water by using some chemical compound is burning issue of research interest in analytical chemistry, but scale detection and wall thickness measurement using ultrasonic technique has proved to be an immediate remedial measure to this long-term problem. Basic principle of ultrasonic inspection. At the power station, chemical overhauling has to be hastened in order to resume power generation as soon as possible. Under this circumstance, the effort are to get the most accurate thickness measurement at a minimum time. Again, it overcomes the limitation of conventional uses of attenuation in presence of air, and as a result, no coupled application is required for its operation. Areas of operation at the thermal power station. Basically, a thermal power station consists of furnace to burn the fuel, steam generator or boiler containing water. Heat generated in the furnace is utilized to convert water in steam. Main power units such as an engine or turbine to use the heat energy of steam and perform work, and piping system to convey steam and water. In addition to the above equipment, the plant requires various accessories depending upon availability of water, fuel, and the service for which the plant is intended. Practically, boiler units are shut down for capital overhauling, the vital time for NDT operation. Operation for wall thickness measurement and scale detection are conducted on various boiler accessories like superheater, economizer, heater, and other boiler accessories which remain in contact with steam. Next is visual inspection technique, theoretical survey and basic principle. Detection of any crack or surface failure can be considered as visual inspection. In industrial application, there are certain regions that cannot be accessed through the naked eye, and their remote visual inspection method proved to a promising solution. Even the facts recorded by this instrument can be further utilized for the purpose of R&D analysis. At the thermal power station, visual inspection are mostly performed manually, but however, in recent years with prospect of technology, certain advanced methods are used. Areas of operation the thermal power station. Mainly those locations that cannot be reached by the naked eye come under its area of operation. This include the diagram of turbine during the short time overhauling, the internal surface of tube of any location, boiler. It provides a sharp magnified image that can detect crack or any type of surface deposition, thereby visualizing surface topography. Rapid rate of inspection as a part of regular maintenance can be frequently conducted by the field engineer without disturbing much the turbine assembly at regular interval, which will act as preventive measure against serious damage and thereby saving time and labor, hence reducing the frequency and duration of short-term overhauling duration. Certain useful and user-friendly features of this instrument: its operating temperature of -4 degrees Fahrenheit to 115 degrees Fahrenheit and storage temperature of -13 degrees Fahrenheit to 114 degrees Fahrenheit make this fully compatible for utilization at thermal power station. Always articulation of the camera feet at the top of its probe make it possible to reach at those places which cannot be accessed by the naked eyes.